Hello, testing.
Wait.
Okay, you can hear me,
Yes.
Okay, now better. I don't know what happened just now. Okay, so are you actually talking about week 35, right? Correct. Mm-hmm.
Yes.
Okay, now so any question regarding the previous week? We were doing something like this trigonometry. If no problem, then we'll talk about week 35. So sorry. So of course, I want to talk about cheat sheet first because it's actually related in to what you have learned. So last week, I mean the previous week, we did this. We call that the trigo ratios, like at different quadrant, right? I'm sure you are okay with that. Um, it's only until maybe last week, we were doing something that has got to do with the sketching of the trigo functions. Okay, so last week, literally most of the time they were doing the sketching, and I assume that will be the worksheet in front of you, right? Do you have your worksheet with you actually?
I can find the online version.
Okay, you can find the online version now. Okay, so of course, okay, then I'll share with you this thing first, because last week what we did was actually sketching of the functions. Okay, so just give me some time to explain to you how it works over here, then I'll go with you on the solutions for all these things. Okay, so what I did with them mainly was on the sine and the cosine graph. Tangent, I didn't touch that because I wanted them to focus on sine and cosine first. Okay, and then of course the sketching actually involves knowing things like amplitude, period, as well as so-called I call that the offset. That means when you do a plus C. Okay, so maybe you just give me some time. I will want to call out the GeoGebra for you. Okay, okay. Do you see my screen over here? Okay, I hope you can see. I'm now calling out the GeoGebra. Can you see my GeoGebra over here, Qinghan?
Yes, I can see.
Okay, now so basically this is the GeoGebra. So let me just explain to you this regarding the sine wave. Okay, for instance, this is y is equals to sine x. Okay, for instance, now let me expand this for you. Okay, so basically, a sine graph, okay, call that a sine graph. It actually is like a wave, you notice, Now, so the wave actually start from zero. You notice it start from zero and then move up, and then after that it comes down, and then it goes up back again. You notice, and this is called one cycle. One cycle means okay, after one cycle it repeats itself. Okay, and this cycle, usually we call that a period. So a period is whereby this thing will actually complete its one cycle and then repeat after that. So if you notice for sine, right, it's going to be up and down. So from 0 up to 6.28, okay, in this case, that will be considered to be one cycle. Okay. Now, and along the course, if you don't understand, you just stop me. So now this is called the sine graph. Now we can do some changes to this sine graph. So let me share with you now what if I do something else. Okay. So now let me use the same sine graph and I will move it up. Okay. I'll move it up and that will be to do something like this. You notice something? This literally moved the sine wave up by 1 unit. Okay, let's say for instance it's supposed to be 0, so it didn't start at 0 anymore because when it is supposed to be 0, we add 1 to that, so it moved up by 1 step. So this is actually moving the sine wave up by 1 step. Okay, and of course I can also move it to maybe a -1. Okay, so no brainer, if you see that this is -1, what happened? It actually move it down. Okay, so instead of 0, now it is at -1. Okay, so far everything is okay. So this is considered to be a change in the sine wave in terms of its y value. Okay, so this is what you must know first. Okay, that means if you add something to this sine graph, okay, be it +3 or -3, it will change the position of it. It will either move up or move down. Okay, This is later on I'll teach you how to sketch this, okay? And then of course I can do something else, okay? Let me just remove this red sine wave, and let me change something now. Now I'm gonna increase the frequency, okay? What does it mean by increasing the frequency? So observe this with me. I'm going to increase it by maybe 2, okay? So what does it mean? If I increase frequency, it looks like this. You will notice something. For our sine wave right now, it actually repeats itself at around 3.14, okay? Instead of repeating itself at 6.28, it can actually generate 2 sine waves in from 0 to 6.28. So what does it mean? It means that now my period has changed. Instead of having a period of 6.28, now the period is actually 3.14. Now, why is it like that? It's because I've increased the frequency. That means I've increased the x to 2x. So by increasing x to 2x, what happened? The frequency actually increases. You notice, within this period from 0 to 6.28, I am expecting only 1 cycle. But however, making it a 2x, I have now got 2 cycles. Of course, no brainer. If I do 10x, you will see that, okay, maybe just very interesting. Let's do a 5 instead, okay? You will see that I have actually increases it by 5 times, you know. So instead of having it at 6.3, now you see 1, 2, 3, 4, 5. There are 5 cycles now, supposedly, right? So this is what we also will learn later. How do we sketch this? And of course, there will be a combination. That means we do a maybe an increase in frequency, and then we add maybe 2, and then it just changes completely. So this one we will sketch that, okay, just to let you know. Right now, so for our context for today, of course, I'll be using the so-called the worksheets, right, to explain to you how it's done. All right. Now, there will be 2 parts to this sharing. The first part will be to ask you to sketch, okay, to sketch this. And the second part will be to give you a sketch and ask you to find back the parameters, okay? So this is what we are going to, there'll be 2 parts, so just to share with you. And if you have any question, do just shout out over here, okay? So this is what I want to do, okay? So before we begin, you need to know how the sine graph looks like, okay? So please, if let's say you have your e-copy right now, you can have a look at it. The sine graph actually, you know, it looks like this, okay? Like I mentioned, it actually moves up and down, okay? So to share with you what is the thing, the note you can take down, maybe you can write down on some papers first, okay? Which you can write in the notes. Is that how does a sine graph look like? Okay, so maybe I'll just share with you first, because you need to know the shape of it first before we sketch. Regardless of whether it is actually 2 sine x or sine 2x plus 1, whatever, as long as it's a sine graph, you must actually know how it looks like, you see. So basically the shape of this, right, is supposedly going to be like that, okay? Up, down, okay? This is actually a sine wave, okay? We call that y is equals to sine x, okay? And of course, this is x, this is y. Okay, please take note now. Now, when we look at this sine wave, okay, just a sine x, a simple x, okay, you will notice that there are basically 4 intervals that I want you to take care of, okay? Now, it actually coincides with our quadrant we learned. All science teachers are crazy. It coincides, in fact. In fact, that's why we learned that before we do the graph. And how come it coincides? You look at it this way, okay? Let's just talk about sine, shall we, okay? So, for instance, okay, let's look at this. You can also use your calculator if you do not mind. Now, so what are these intervals I was talking about, you see? So basically, if you notice, I was actually looking at our GeoGebra, remember? Now, so let's talk about this in the GeoGebra. Let me just expand this for you to see. Right, you notice something, okay? I want you to observe this with me. Just now at the GeoGebra over here, okay? Let me just remove this very quickly and let you see. You will see that it actually start at 0 and finish at around 6.28, right? Now, what does it mean actually? What is a 6.28 in this case? This, if you convert it to degrees, right, it is actually 360 degrees, okay? So let's talk about degrees, okay? Then later we can transit to, radians, but it's the same in fact. So basically over here, this is actually 360 degrees, okay? Just to share with you. And over here, we can split this into 4 intervals, okay? So knowing the period is important because we can actually, get the intervals. Okay, later as I do, I will explain even more, so do not worry. So what happened is this. Then of course the 4 intervals, if you divide 360 by 4, right? Every interval is supposed to be at 90 degrees. Okay. So what happens? So if you notice, I'm just split this up like that. Okay. It helps us in our drawing where we separate it into the intervals. So basically it looks like this. Yeah, and of course this is 270. Okay. Right, so this is what you must know. Obviously, the 180 is here. So what happens is this. This is called a sine graph, and I've actually indicated in the interval. And when you look at this, sine 90 is actually the highest value. And if you press your calculator, it is actually 1. Okay? And if you press, same thing, if you press sine 180 degrees, we are expecting it to be 0. And the same thing happens if you press sine 270 degrees, it is actually -1. Okay, so on and so forth. And it actually satisfies the quadrant that we learned. For instance, right, you notice when I share with you guys that okay, sine can only be positive in the second quadrant and the first quadrant. So what happened is this. After 180 to 360, all these sine values are negative. So yeah, it's legit. If you notice on my sine graph, notice all these are below the positive x-axis. Is legit. So it satisfies the condition that we have learned previously, right? So there are no conflicts over here. And the sine graph is a visual, representation of what we have learned actually in terms of quadrant, you see. So it's okay. It is all the same. So if you press calculator, for instance, sine maybe 300, we are expecting it to be around here, you see. So that's why we draw this graph. Drawing this graph, you can also see something. The highest value, that is what I call the maximum, is actually equivalent to 1. So basically, the maximum value over here is actually 1. Okay, and incidentally, this is also the amplitude. The amplitude, let me just share with you, the amplitude that we are looking at is basically equals to 1 in this case. And where do we draw the 1? We draw the 1 actually from this value in front of the sign. Okay, so for instance, if now I have changed it to y equals to 2 sine x, for instance, let's say this is now 2 sine x. Your amplitude now is not going to be 1, it's going to be 2. Right, so in this case, if it's y equals to 2 sine x, the amplitude is actually 2. And if the amplitude is 2, guess what? Your waveform will change. And it's not that big a change. It's just that your maximum and your minimum in this case has changed to 2 and -2. So literally, it just multiply whatever we call that the value of y by 2. And you will have a different in terms of the values. But the shape is the same, you notice? So that's why it's actually pretty easy. If let's say they ask you to sketch a 2 sine x, you should change your amplitude to 2, obviously. And then the maximum, minimum will change accordingly. Okay, so please take note of that. All right, so this is what I need you to know. Okay, so the first thing to take away from is the first thing is the shape. Okay, let me just write that down. You probably want to write that down too. You need to know firstly, how does the sine wave looks like? Okay, the shape of it. The second thing is what is the period? Okay, and by default, of course, definitely a sine x is actually supposed to be 2 pi or 360 degrees. Okay, that is for just a normal sine x. Okay, And of course, you also need to know the amplitude, okay? Like I mentioned, looking at what is in front of your sine x. If it is equals to just a 1, then your amplitude is just a 1, okay? So to speak, that's the third thing. All right, and of course, these are the things that you need to do first, okay? Shape, period, and amplitude, okay? So now let's go to our so-called lesson first, okay? All right. For this first exercise you see in your notes, this one I would like you to try it first, okay? Because if you notice on page 1, I do not want to go through a review here because I want to read, okay? I want to read the sorry, let me make it smaller. Sorry, my bad. Okay, let me make this smaller a little bit. For you notice page 5, I would like you to try yourself first, okay, by reading the example, okay? Because this one I believe you can do it, so I don't want to spend too much time on this. This is actually very simple. You try on your own, right? If you don't know, you just send me and ask me, okay? What I want to do today is to demonstrate the sketching, okay? That's why over here I want to demonstrate to you how do we sketch this, okay? Now, I talked quite a bit just now because if you notice our worksheet over here, the example 9.9 actually jumps straight right into the sine wave. That is a little bit too much for some students. It's like if you notice, right, example 9.9, it asks you to actually sketch this graph, you see. Literally like what, you have got 3 sine 2x plus 4. That is a little bit to actually digest, right? Okay, because you need to know how to draw sine 2x now. You also need to know how to draw sine 3 sine 2x and then 3 sine 2x plus 4, So there's a lot of component inside that you need to see. So that's why I'm going to share with you how it works, okay? Just by purely doing this for you first, okay? So now, of course, they have drawn this. You can just ignore it for a while because I want to draw for you this y is equals to sine 2x plus 4. Or maybe I could draw the exercise 9.9 and then you look back for example 9.9. I guess this can also work out. So instead of drawing again example 9.9, I will draw exercise 9.9 instead. So that will be below. Later, when you have got the hard copy or you're looking on online, right? I actually kept the hard copy for you. This online, you just have a look at it. So just read the example after you have got a hard copy then, okay? I will share with you how to do this then instead, okay? So sketching something like this, okay? Y equals to 4 sine x minus 1, okay? Now, what you need to know, like I mentioned, is the amplitude as well as the period, okay? So I want you to see, very first thing is, they ask you to sketch y is equals to 4 sine x minus 1, okay? Now, catch this, this is actually the range, okay? That will be from 0 to 2 pi. So when they say 0 to 2 pi, you must draw from 0 to 2 pi. And because this is 2 pi, you must express it in terms of radians, okay? So you might ask, okay, then how can we do this, right? So let's see how we can do this, okay? First thing, let's answer that question first. What is the amplitude of y? So like I mentioned, you will have to look at the front of this. This is actually 4, right? So you will say that the amplitude of y is actually equivalent to 4. Okay, please write that down. Right, the amplitude of y is actually equivalent to 4. I believe we are correct. If you can, when you get back the notes, you can actually have a look at behind something here. Okay, so this is to share with you. This is actually what you have lah. Okay, that will be equals to 4. Now, so coming back to this, so that means the amplitude is looking at whatever is in front of your sine. So in front of sine x is 4, right? Then the amplitude of y is just a 4, okay? Of course, then they ask this thing, okay, you need to listen now. How do you find the period of y, Okay, the period of y is like, okay, I'm just asking you what is the period of this graph, Now, don't forget the period is actually affected by this thing. Remember, I did a sine 2x, remember, and it changed the period. So, strictly speaking, right, period, you only look at what is about your sine x over here. You have to look at what is here instead. All right. So period, look at this. This is actually sine x, or so to speak, is actually sine 1x. So your period is actually 2 pi over 1 or 2 pi. Okay. All right. Can you catch? Basically, that is the period. That means from 0 to 2 pi, this is the period that we are going to draw. Okay. Catch this.
Wait, what does the period mean?
Okay, like I mentioned again, the period actually means the graph goes up and come down one cycle.
Oh,
So notice 2 pi over 1 is actually just 6.28. Actually, it's also 2 pi. So it's just a normal sine x actually. This is actually one period. Can you see? So the period range from 0 to 6.28 for this one, right? And for our question, it's actually the same also. It's like, this is just like a normal x, you notice? Right, so and I was just sharing with you, you remember just now we were doing sine 2x, right? Now, if let's say I'm going to have a sine 2x, let's just let you have a recall. If it is sine 2x, right? If it is sine 2x, the period will change like I told you. How does it change? 2 pi over 2. The period becomes pi. That means from 0 to 2 pi, it will have 2 times of it. So the period is pi now, you see. So I'm going to convert it for you to see again. Now let's change this and change it to 2x now. Okay. So now you see the period. Look at the period. Look at the graph visually. You look at this. You notice it goes up, goes down at 3.14 instead of 6.28. Why? Because it has changed the period. So why did it change? Because it is actually 2 pi divided by 2. Why? Because if I increase the frequency, right, the period will actually reduce. So in this case, instead of taking 6.28 to complete one cycle, it has completed one cycle within the 3 point something. So that's why in this case it's 3.14 or pi. All right, hope you can catch this. So that's why this is the one that can change the period. All right, now you don't have to think too much, okay, how to draw this, but just understand for the time being that having a change in this will change the period. Okay, later I'll draw for you to see how is it different. But for the time being, we go for sine x first because it is just 2 pi over 1 or the period is just 2 pi. And we will just draw one cycle only. That means up, down, that's all, because this is the range that they give us to draw. Okay, so now how to draw this? Okay, so let me just share with you how to draw this. You can draw this or you can just record it or you can screenshot this because I want to share with you how it is done. Okay, so I'm going to go very slow, don't worry. Let me just draw 4 sine x for you to see. Okay, you don't draw yet. Let me just share with you how to draw 4 sine x only. So you don't draw. I will just share with you first. Okay, let's say for instance you're doing 4 sine x. Okay, what happened is this. 4 sine x is supposed to be like that. Okay. Okay, and of course, like I mentioned, it's go up, go down, right? Okay, I'm drawing with a mouse, that's why it looks a bit bad, but you can draw better, don't worry. Okay, so basically now this is up, down. All right, and I told you 4 sine x means times 4. So basically this is going to be 4. Okay, and this is going to be negative 4. Okay, because the amplitude is 4, so this is what we know. And the interval is divided by 4, so go for the interval also after you got a period. So basically this is 2 pi. Okay, now question is this, because this is actually in radian, right? So you have to actually express it in terms of radian as well. So of course, if let's say you got calculator, that works better because you can actually use it like a fraction type. So what do I mean by that? Have a look at this. So for instance, if you're given this one, right, you know that the period is like that. You will divide by 4, like I told you, to get the interval, right? So dividing this by 4, right? So that will be 2 pi divided by 4. And you notice every interval is supposed to be pi over 2. Okay? Can you follow? So basically there are 4 of them. And where are the 4? The first one will be this one. The second one will be this one. So every interval is pi over 2. So this is going to be pi over 2. Okay? You notice, and the next one, okay, then this is going to be 2 pi over 2. In fact, this is going to be 2 pi over 2. Okay. Now, because why? Because it's supposed to be like this. This is supposed to be 1 pi over 2. This is supposed to be 2 pi over 2. This is supposed to be 3 pi over 2. Okay, and that is supposed to be 4 pi over 2. But we have to simplify ma. So for this two, no need to simplify. This one, 2 pi over 2 becomes a pi. So that's why we can say that this is just pi. Okay, and of course 4 pi over 2 is also 2 pi. So that's why we have it like this. Okay, so not too difficult. Whenever you find the interval, you just keep on adding the interval. It's very simple, trust me. So in this case, it's pi over 2 as our interval, right? It's a 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Done. So this is what we have. You see? Now, this is only y is equal to sine 4x. You see? My question is not just plotting this. My question is actually plotting -1 also. So how do we do that? Okay, so now here comes the thing that I need to learn. The olden way of doing this sketching is to sketch this first and then shift it by 1. But nowadays, we don't do that. Instead, we will have to do something else, okay? Do what, you might ask me. So let me just return back to the normal. Okay, so what do we do if, let's say, there is a -1 here? Okay, so if that is a -1, we will have to do it differently. A little bit different, okay? How different? Something like this. Okay, I want to catch this with me. Okay, and we want to observe. Okay, now, so for instance, if you are given 4 sine x -1, we are being mindful that there is a -1 here, which brings it down. So when you are brought down over here, right, what happens? Okay, so you will have to observe with me how this is done. Okay, all right, and catch this now, huh? We have to draw a imaginary line to help us. Okay, this imaginary line will be -1. Okay, and why am I drawing that? Because I'm gonna construct my wave starting from this imaginary line. So remember, as the first step, because there's a -1, draw an imaginary line at -1, okay, to help you in the sketching. Okay, we don't sketch this and then move it manually by 1. No, we will actually draw an imaginary line at -1 to help us to sketch this. Okay, so understand how it works. So this is -1. Fair enough. Okay, and the question now is this: you must understand that because this has changed, your maximum has changed. Okay, so this is what we call max. So you need to write down somewhere. Okay, the max in this case, the maximum is actually equals to the amplitude for -1, which is equals to 3. Okay, so let me repeat. The maximum is actually 4 minus 1 equals to 3, which is actually amplitude minus offset. I call that the offset, but it's actually called constant, but I call that the offset because it changes everything, you see. So I always like to do like that. Okay. Now you might ask, then is it minus? Why is it minus? Okay, because I literally borrowed the -1 here. Okay, so in this case you can call it plus offset. Okay, so maybe I just write plus offset. Okay, because the offset can be negative as well. So just amplitude plus offset. Okay, if let's say the offset is negative, then it will be minus now. Okay, so in this case it's maximum plus. Okay, just put the formula for you plus -1. Okay, so that's not to confuse you. Okay. Right, so this is what is supposed to be the case. That is the maximum, okay? What about minimum? Okay, same thing. Minimum will be, of course, the, in this case, expect it to be like that, okay? I don't want to put a negative anymore. I'll just show you the formula. It's literally just -4 -1, okay? Which is actually equals to 5. Okay, so this is the maximum value now. The minimum value is -5. Okay, so why do I need that? That is important because I need to sketch it nicely. Okay, so you notice just now it was very easy. I just up down, but now since knowing that the maximum and minimum has changed, right? I will actually put the value there too. For instance, let's say this is 3, right? Let's say, let me just give you a bit more space so that it looks more symmetrical. Okay, Let me just have more space for my okay, let me just do some more because I need to have at least three. So 1, 2, 3. Let's put a 3 here. Okay, this is the 3. Okay. Now, even though they say sketch, but we try to sketch nicely, that means being mindful of what we are doing. Okay, so this is 3, and of course, the minimum will be 5. You know, so 1, 2, 3, 4, 5, something around here. Okay, 1, 2, 3, 4, 5. Okay, roughly here. I'll just make this so. Okay, okay. And follow, huh? So now putting this down, right? Some students will think that, okay, I want to be even more accurate. Then you may, of course, draw another dotted. Use ruler, obviously, lah. Huh? Please use ruler, huh? You can do that, no problem. To give you the maximum range, okay? You can, just draw like this. Now, some students, they even better. They go and draw square grids themselves. But exam, you don't have time to do that, so don't do that. Instead, just draw dotted line, okay, to help you in your sketch, okay? All right, so this is what we have done, okay? And then, like I told you, we must know what is actually the period. Remember? So looking at this, the period is the same. Okay, I'll write this down. You can write that also in your working, or you can screenshot. Anyway, I've actually done a recording of this in case you need a copy of this. Period is actually equals to, like I told you, 2 pi over 1, right? So that will be, of course, literally just 2 pi. I'll just write that down. That will literally be just 2 pi over 1, okay? So 2 pi over 1, like I mentioned, you also need to know your interval. The interval, okay, is actually equals to, right? So important is actually 2 pi divided by 4, okay? So 2 pi divided by 4 is actually equivalent to pi over 2. All right, you got that? So now, knowing this, it's the same thing. So basically, the interval, I will have to put it in, okay? And still on the 0, the x-axis, still the marking is still here, okay? So we can do that. Okay, let's just separate it, you know, equally. Okay, I hope I can do that. You guys can do even better. Okay, so I will do it like this equally. Okay, and of course, pi over 2 is here. Okay, let me just quickly write that down. I will draw very slowly because here I'm using mouse to draw. Okay, so it's a bit weird. Okay, a bit odd. Okay, so this is 3 pi over 2, and this is actually 2 pi. Okay, now you're gonna see what I'm gonna do. I am going to put in the points. Okay, and how does it work? For instance, you're supposed to start at 0, right? No, but this time around, you will start at -1. You know why? Because it is 0 minus 1. So it's supposed to be -1, right? Trust. The next thing is pi over 2. Look at this. Pi over 2 is supposed to be at the max, right? So in our case here, it is actually at 3. Okay? And then a pi is supposed to reach back at 0. Okay? And in our case here, it is supposed to come over here. Okay. All right. Okay, it looks a bit odd because it's actually more spacious here. Okay, but you roughly know what I mean. Okay, and then at 3 pi over 2, I'm at the minimum. So basically, I'm actually over here. Right, and then at 2 pi, I'm back to -1. So it's going to be like this. You notice? So what happened? After I've done something like this, I'll try to draw, but don't try to be too pointed. It'll be a little bit curvy. That's all. Can you follow? That is how we can draw it, something like this, okay? And that will be actually y is equals to 4 sine x minus 1, okay? Now, 请看, if let's say you have drawn this already and you're not too sure, right? You can go to GeoGebra or Desmo to check, okay? So let's check this. Let me just check this for you. Y is equal to 4 sine x minus 1. Let's check this whether it's the same, okay? So y, okay, let me just remove this, I think. Okay, y is equals to 4 sine x, right? Okay, hope that it works. Okay, catch. Oh my god, so big. Let me just make it smaller. Okay. Okay, so something like this. Okay, but of course you have to start from 0, so you don't have to. You can just ignore this part here. Okay, and you know this is something along here, so the maximum is actually 3, and it cuts at maybe around at about 3 at the 0 axis. Okay, so looking at our answer, is it cut at 0? Yeah, roughly around here, right? Yeah, that's how we got it correct. Okay, everything like this. Okay, fair enough. If you have a question, please ask. Okay, I'll give you some time to think. Do you have any question regarding sketching of the sine graph? Okay, please ask if you have, because I'm going to talk about sketching cosine now. Okay, so I've been quite an hour on this. Do you have any question regarding plotting of sine graphs?
Not really. I understand. It's very clear.
Okay, good. So now we're going to go into cosine graph now. Cosine graph, how does it work? Okay, so let's go back to cosine graph. So I'm not going to show you the GeoGebra for cosine, but I'm going to instead, right, explain to you cosine graph just by sketching. Okay, so in fact you can also see it over here, but how does it work? Okay, is in fact cosine wave and sine wave are related. That's why you see previously, I think last week they say that, okay, cosine x is sine something minus 90 minus x. Okay, let me now draw for you a cosine wave. Okay, but basically the concept is the same, just that the shape is not the same. Okay, for instance, cosine is something like this. Purely by cosine, that will be cosine x. Okay, so cosine x, it looks like this. Okay, instead of starting from 0, it start at the maximum. So go up, down, and then right up. Okay, it's like we call it a trench, I should say, and that means starting at the maximum first. Okay, so what happened is this for a cosine is a 1. Minimum for a pure cosine x is a -1. Okay, now same thing. If I have this as a cosine x, okay, the period is actually 2 pi over 1, okay, which is actually just 2 pi. Okay, so now let me base on this and share with you, if let's say it's just a cosine x, what are the intervals? Okay, so let's just write that down. For this one, the amplitude is actually equals to 1. Okay, right, that's for sure for this one. Okay, and what is the shape? Of course, you should know that already. So the shape looks like this for cosine wave. What is the period? Okay, that's now something we need to talk about. The period, like I mentioned, is actually 2 pi. Okay, of course, the amplitude you should know is also 1 in this case. Okay, now like I mentioned just now, you should go for 4 intervals. Okay, so what are the 4 intervals? Okay, the 4 intervals are the same as 2 pi over 4. Now, it can also be 360 divided by 4, just to share. Now, you will notice that's why I did over here. It can also be 360 divided by 4. It depends on the question, okay? So if they want it to be drawn in radian for your angle, for your degrees, then different changes, okay? So just take note, if they want it to be radian, then you have to follow suit. So in this case, it's pi over 2. Let's say we are using radian. And as mentioned, the 4 intervals will be here, obviously with 0 lah, then it's pi over 2. All right, so you just add, keep on adding. Like I mentioned just now, this is pi. This is 3 pi over 2. This is, of course, last but not least, 2 pi. Okay, right, this is like that, no? You notice. So knowing sine graph is actually very good, because knowing the concept of sine graph also helps you in finding the same thing for cosine, just that the so-called the shape is not the same, that's all. Okay, all right, hope you are clear with this, because I'm going to explain to you the second part of the question now, and that is how can you sketch this cosine graph. Okay, so remember, it is actually like a trench from top to bottom. Okay, let me just go to that page first. Okay, so I'm going to draw on this because they mentioned on the same diagram. Okay, on the same diagram. So they want us to sketch this. Okay, All right, so I'm not going to touch this yet, but I'm going to draw a 2 cos 2x for you to see how it looks like, okay? Because you have to be very careful. The period is not the same here, okay? So I will draw it here first, right? And then later on, I will just copy over there. So I will erase this and sketch a simple 2 cos 2x first, okay? So I'm not putting in the offset, or we call it the constant. I'm just putting in the trigger function purely. So how does it look like? Let's talk about this, okay? Just a very quick one. So if I'm supposed to sketch this, okay? Now be careful. The amplitude has changed, okay? So it's no longer um, maximum in this case. Maximum is no longer 1 but 2 in this case, okay? So just take note of that. And because of this, it will look like this. Okay, still the same shape, but this is going to be 2, okay? And this is going to be negative 2. Even though I said that the shape is the same, but there's something to be mindful of, because this has changed, the interval has changed. That is actually a small headache to some students, because an interval has changes. This one might not fit exactly, so you might need to put in more markings, okay, to satisfy this graph, you see, because it is now actually faster. So you have to be more precise, so to speak, you see. So why? Look at this. The period is just going to be pi. Okay? So now if the period is pi, remember I asked you what is interval? Interval is pi divided by 4, right? You notice? Instead of pi over 2, like we did just now, look at this on the left side. Our interval just now was just pi over 2, you notice? Now you have it, you have more things to add. Your interval has now changed to pi over 4. Then you might ask, sure, then how to do? Same thing, same thing. It is just like that. First thing is first thing obviously is 0 lah. Then you have got the pi over 4. Then you have got the 2 pi over 4. Then you have got a 3 pi over 4, so to speak. Okay, so let me just put it in from here for you to reference later. So you will definitely start with 0, and then pi over 4, 2 pi over 4, 3 pi over 4, and of course 4 pi over 4, okay, which is going to be pi obviously lah. Now, don't forget, this is only one cycle. Your question, you will notice, must draw until 2 pi, Look at this. Means that you need to draw twice, because our first cycle ends only at pi. We need to do 2 times. Can you see what I'm trying to say? So that's why some students hate it when one graph is x, the other is like 3, 4x, then they will really think, oh my God, we need to draw 4 graphs over there, So that's why they don't like it, you see. But nevertheless, if you know the concept, go for drawing, because there are marks for this, you see. So go for all the marks, because you can do it if you know the concept. Yeah, so in this case, okay, let's just reduce it a little bit, because you see, if I'm going to put in until 2 pi, then it will have to act like this. So let me just list it below for you to see. It will have to be obviously 0, right? And then pi over 4, there will be 8 interval because I need to draw it twice, and every period is 4 interval, so there'll be 8 of them, so it's legit. So the other one is pi over 2, and 3 pi over 4, remember? Just write this down. And this is 4 pi over 4, which is actually pi. This is 4 pi over 4, I repeat, 5 pi over 4. Okay? 6 pi over 4. But 6 pi over 4 can be reduced to 3 pi over 2, okay? This is 6 pi over 4, 7 pi over 4. And then 2 pi, or 8 pi over 4, okay? So all this, some of them are already indicated there. we will put in for them, okay? So please understand that all this, I will gonna put it inside to put in to do the best sketching, okay? So I'm gonna keep this. I will erase the graph, but I will keep this so that later on it's easier for me to do. So I'll put this in first. Okay, just give me a minute. So let me just keep this. I want to keep this. And the rest, I'll just need to erase, okay, because I need the space. Okay, I will keep the space. So this one, I will just put it here for you to see the shape looks like this. So what happened is this, okay, now we're gonna sketch this on the same diagram. Okay, wow. Is it possible? Of course it is. Okay, so now look at this. So very first thing, if I'm gonna sketch this, I need to know what is the maximum value. Okay, but remember what I told you? Okay, since this is actually plus 2, I will draw a dotted line at plus 2. Okay, now because I'm doing it on the computer, I will change it to a different color for you to see. Okay, if you don't mind. Okay, for you, maybe in the exam, you can use a darker pencil, I guess. Okay, so let me just change this to maybe a red, okay, to show you the different thing that I can do now with a different graph. First thing, because there is a constant of plus 2, we draw a dotted line at 2. Okay, so it's a little bit tricky. So okay, so basically the 2 comes in 1, 2. So basically this is going to be here. Okay, right. So this is the Quinson line, I call that. Okay, so basically this is like something here. Okay, all right. So this is actually 2. Just my indication from myself. This is 2. What happens is this now, we need to find what's the maximum value. Okay, now remember, maximum value is not that difficult. For this one, the maximum value has changed. You can edit yourself. I'm going to change this maximum value. So the maximum for the second graph, right, is going to be 2 plus 2. Okay, okay, so it's going to be 2 plus 2, which is equals to 4. That is the maximum. Okay. The so-called the minimum is going to be -2 plus 2, which is 0. Okay. All right. So basically, this is what I have. So basically, maximum 4, minimum 0. Okay. Possible or not? Let's try. Okay. So now you notice my graph, right? Just now I did. I don't have a 4. So I will try to expand a little bit more. It's possible since I'm sketching. Yeah, since I'm sketching, it's possible. So basically, let's just lift it up by a little bit more. Okay, let's change it to blue, else it looks very funny. Okay, so change it to blue first and extend it first up here. Okay, so basically this is 4. Okay, all right, and because this is my Quinson line is at 2, the 4 is the maximum, right? I can choose to draw a dotted line, no problem. So over here, draw a dotted line here. Okay. Okay. All right. So I want you to look at this with me. So this is here. Chingan, have a look at it. For our instance, if let's say the shape looks like this, remember for the normal one, it's supposed to be 0, right? And then of course, for this case, this is going to be pi over 4 instead already, huh? This is going to be pi over 2. And this is going to be from 3 pi over 4. This is going to be pi. Okay. And if you're going to draw it again, it obviously looks like this. So you need to draw twice. Okay. It looks a little bit funny, but you know what I'm saying. So basically now, this one also. This one is going to be 5 pi over 4. Yeah, and then of course this is 3 pi over 2. And this is going to be 7 pi over 4. This is going to be obviously
Wait, for cosine graph, does it always start from the top?
depends. If let's say they say negative, then it start from the bottom. You flip it already,
Oh,
if it depends on the question. If they negative, then you flip already. But you see, you don't believe. Like, let me try to share with you. For instance, let me just use a cosine here. You see, let me share with you. Let's say just a normal cosine. Normal one, you see, start from the top here, purple line. You see that? But if okay, let's remove this. Just remove this for a while. Okay, you see, it start from the top, right now. But if I negative it, oh, then it's a different story. You see? The 0 is here, but it's here. So you will flip it. You see? But for the time being, you do the positive side first, okay, so that it doesn't confuse us. You see? So you can do that first. But yes, for a normal cosine wave, it starts from the top. Okay? So in this case, you can also press your calculator if you don't believe me. You can use your calculator. You press cosine 0. Cosine 0 is actually 1. You see? So it's always from the top. Okay? Now, for our instance right now, right? Let me see. Now, let me now get ready to sketch. Okay? So, but being mindful that the quiescent line for that is actually now at 2. Okay? So now what is going to happen is the 4 in this case, it will be here actually will be a 4, right? Just to share, and this is actually a 0, something like that. And this is going to be 2. Okay, but let's see how it works over there. Okay, so for instance, at 0, right, x is equals to 0, I'm expecting a maximum value because it is supposed to start from the top. Yes, it's going to be at 4. Okay, and let me continue. At pi over 4, it is supposed to be 0, right? So basically at pi over 4, in my case here, okay, I didn't have pi over 4, so it has to be greater over here. Okay, so this is pi over 4. Let me just share with you. So that's why I share with you. Some students, they don't like it because you have to put in more value. So in this case, I'll just do some more. This is pi over 2. This is 3 pi over 4. Okay. I think it will touch this one, but I'll just, maybe just put here 3 pi over 4 just to, I don't know whether it should touch. And this is 5 pi over 4. Okay. And then let me just fill it up. 3 pi over 2. Wait a minute. 3 pi over 2. And then this is 7 pi over 4. Yeah, something like this. Oh my god. Give me a minute. What happened? What happened? Why is it like that? Okay, maybe it's the wind now. Okay, just let it be. Sorry. I think it's the wind, sorry. I don't know what is this. Okay. Can I erase this? Okay, good. So you see or not? So now let's sketch, okay? I know it's a little bit messy, but I'll send you a solution, don't worry, later on. So basically this is here, and we are going to move down, but move down until where? Pi over 4. So it's going to actually move until here, okay? So I'm actually drawing with a mouse a bit difficult. Let me expand this a little bit so that it's easier to plot. Sorry, because it's like I'm using the mouse. Sorry about that. So basically now it has to actually cross from here. Okay, let's move on. So remember the shape is important, that's right. So over here, up, okay, and it has to down over here at the 2, and at 0 it will touch. So basically this is supposed to be here, okay, at 0, okay. So basically up, down, and then at pi over 2, okay, it's supposed to go back to here, okay. So it's going to be look like this, pi over 2. And then at 3 pi over 4, okay, it's going to be at, okay, it's a bit tricky. So basically down, and this is going to be the 0, remember, right? So be 0, and then at 3 pi, it's going to be here. And 3 pi over 4, okay, it's going to be in the middle, and at pi, it's going to reach back here again. Okay, it looks a bit weird, so I will want you to draw on your own, but let me just put the GeoGebra for you to see. Very hard to draw on the computer. You see, so basically what you have, what you're gonna draw is like this, okay? 2 cosine 2x plus 2. Okay, okay. It will look like this. give me x. Okay, it looks like this, ma. So it's actually supposed to be like that. You can actually snapshot if you want. And what we had done previously was this. Okay, y equals to sine 4x minus 1. Okay, so was it sine 4x minus 1? Let me just see. The question is 4 sine x minus 1. Sorry, my bad. 4 sine x minus 1. Okay, so you see what happened is this. This is supposed to look like this. You see? So this is actually going to touch here. I told you the minimum is 0. So basically this is what is supposed to be done. And in our case here, maybe I snapshot for you for a while. I will expand this for you to see. They want it to be until 6.28. So it's going to look like that. Okay, so roughly it's going to look like. So let me just take a snapshot for you to see. Okay, let me just snip it and then send it to you so that you can see in your WhatsApp. Okay, for instance, it's supposed to be like this. Okay, I'll cut it right up to 6.28. Okay. Okay, so somewhere along here. Okay, so sending this to you, right? You can have a look at it. Okay, just give me a minute. You're here, right? I'll send it to you. And okay, all right. So this is actually what is expected to be drawn. You can expand this yourself. Okay, have a look at it. Okay, all right. For this one, okay or not? This one, so far okay or not for this cosine? I know I didn't do it on the graph, but I hope you can understand how it works. It's about the same. Just that for this question, your cosine you need to draw twice of it. Okay, but generally the concept, are you okay so far?
Yes, I understand.
You can understand. So like I mentioned, let's say you draw already, don't know what happened, right? Then you use the GeoGebra or Desmo to actually sketch this. Okay, can So
Okay.
the sketching is only the first part. So do allow me to talk about the second part, which is what if I give you a graph and then I ask you for the different parameters. Okay, so where is that question? Okay, it's actually over here. Okay, it's almost at the end of it. Okay, so for instance, you can use this, you know, this all along you can sketch but I will do that maybe next week to share with you. I did that in class already just to share. Okay, let's say for instance this one. That means they have given you a graph. Okay, where is that? Okay, this one. Okay, can you see? Look at this with me. This is not really a graph but something similar. For instance, exercise 9.13. They give you amplitude, they give you maximum value, they give you period, they ask you what is A, B, and C. Yes, this is the second part. The first half of the second part, that means I don't give you a graph, but I give you the parameters and ask you to find the function. Now, remember what you did just now was I give you the function, I ask you to find the parameter and then to sketch, right? Now I give you the parameter, I ask you to find me the functions, okay? So remember what is your A? Remember, your A is actually your amplitude. So you notice, right, this function f, it has an amplitude of 3. So you can actually very safely write like this. For instance, fx means function of x, which is like a y, is equals to 3 cosine bx plus c. Okay, hope you know what's going on now. It's like just putting back the value. So remember I shared with you this has always been our amplitude. So that's why this is actually going to be 3. Okay, hope you can understand. And then maximum value is -2. Now remember, when you have a maximum value, it is actually going to be 3 plus c. Remember I told you maximum value plus offset is, maximum value is actually your amplitude plus offset, right? So in this case, maximum value is 3 plus c. 3 plus c is equivalent to -2. So of course, can we find what is actually our C? Obviously, we could, right? That will be -2 minus 3. That will be -5. Can you follow? So I can rewrite this very happily as 3. Yeah, you can ask what you want to ask. If you want to ask, I'll just ask. It is actually bx minus 5. Okay? Can follow so far? That means the amplitude can be easily found by whatever they have told us. The amplitude of f is literally your A. The maximum value, like I mentioned, is actually your amplitude plus the offset, which is constant in this case, that is plus C. So that means 3 plus C is equivalent to -2. So of course you can shift and then find what is actually your your C, which is -5. Okay. Last but not least, how to find your B? Remember, whatever is here is literally going to affect your period. Remember, so it's just like, okay, 2 pi over B is your period, okay? And it's written over here, the period is pi over 3. So what happens? Equate it to be equivalent to pi over 3, okay? And what happened? You probably can remove the pi, no brainer. And then of course, cross multiply, that will be 6 equals to B, okay? And then we can rewrite this. The functions is literally just 3 cosine 6x minus 5. You got it?
Where did the 2 pi come from?
The 2 pi is actually the 360 degrees, you remember?
Oh,
I remember our 2 pi over b, that has to be done. Because remember, for a normal wave, be it sine or cosine, it's always from 0 to 360 degrees. That's why you have a 2 pi. And if you increase your so-called your period by increasing the frequency of x, right? Then you have to divide accordingly. So let's say you have not done any increase, it's a 1 or just a cosine x, right? Then it's just 360 divided by 1, no? So that means that there's no change now. But if you make it like a half x, oh, that will be times 2. That means your period is not from 0 to 360. It's from 0 to 720. So that will change. And that's why you have to use 2 pi over b. In fact, you can take that as the formula to find the period in a graph. Okay? It will always be 2 pi over b in this case.
oh,
Yes,
okay.
it's always like that. Okay, so now you have found this, you can try maybe part B yourself. Okay, but part B is in degrees, so you have to use 360 divided by yeah. So you try it on your own. Once you got the hard copy, no problem. That is this given parameter asked to find. What if you're given graphs? Okay, let's catch this. So I will share with you the example 9.14 and then you can do the exercise. Okay, what if you're given a graph? You see, same thing, you can do it. Just recognize what are all this that you see. Okay, first thing, what is this? Second thing, what is this? Okay, so then we can see. Now, what happened is this. This is your maximum value. Okay, this is your minimum value. Obviously, now, of course. And let's go for the simple one. You will notice. Go for period first. How do you know the period? Remember what I told you, Qinghan? Period is the so-called the time taken for it to repeat itself, you see. So when is it repeating itself? Let's say we start from 0. We go down, go up, go down, 8. Repeat again, right? So here, this is the time that it repeats itself. After this, one more cycle starts. So your period in this case is pi over 4. Can you follow? No calculation in this case so far yet. You can observe from the graph itself that after pi over 4, it repeats itself. Okay, so that's how we know that. Okay, all right. Can you follow so far? Just by observing the graph itself, you know that, okay, after pi over 4, the shape repeats itself. So that will be, of course, the start of another cycle. Okay, so this is already one cycle. Yeah, so we take that as your period. Follow?
Okay.
Yeah, so now done already. Why is it important? Because it is actually going to be giving you the answer for B, you see. Now, if you know the period, like I mentioned, it's always 2 pi over B equals to period. Don't forget. So it's like that. And we can obviously find our B, obviously. Cancel, cross multiplication. B is equivalent to 8. Can you follow? So now instead of saying sine bx, it's now sine 8x. Can you see? Can you follow? So that's how we do that. Can follow, huh? So this is
Wait, is it they gave us the pi over 4?
no. Like I mentioned, no. For this question, no. You have to observe this, that it repeats at pi over 4. You have to observe, how do you know? You see, let me share with you how come. You see, for this one, you have to observe in this case. Like from here, right? It goes and then continue again. It repeats itself. Can you follow?
Wait, I mean like the number pi over 4 is given, right?
They will
The
give definitely.
diagram.
If they don't give, then you have to halve this. That means from zero
Oh,
from zero to power two is 2 period. So you have to divide by two lah.
okay, okay.
Also can lah, but I don't think they are so bad lah. Okay, I don't think so lah. Okay, they will give lah something. Okay, so basically now no this is important lah. Now after this, let's talk about the finding A and C already. Okay, how do you find A and C in the first place? You can do something like this. Okay, you can just add this and this, or rather get the difference. Okay, what do I mean by get the difference? Like because you want to find what's in the middle, ma. You want to find what's in the middle, you need to actually find minus the below. So in this case, look at this. We want to find what's in the amplitude, right? With your this reference from the middle, right? Then you have to subtract this and divide by 2. For instance, let's say I have got a normal sine wave. Let's say, okay. Now, let's say this is actually 2, okay, and this is -2, okay. Right, how do I know that the amplitude is 2, right? Obviously, you can see directly from here lah. But if let's say you're using the formula, that will be 2 minus -2, okay? Right, so what am I doing when I 2 minus -2 is basically adding the two differences, again, divide by 2, right, to actually find the average. So when you do like that, that will be 4 over 2, and this is actually going to be 2. So this is telling me that the amplitude is supposedly 2. And in this case, it's also the same thing. You will take 5 minus -1. So it's basically finding amplitude. Shall I write the formula for you, which you can take note of? Finding the amplitude from the graph is actually maximum minus minimum divided by 2. Okay, shall I just write that for you? It's actually maximum from the graph minus minimum divided by 2. That will be to find the amplitude, which is actually your A only. So basically, finding amplitude is actually maximum minus minimum divided by 2. Please note this down. Yeah. So in this case, it is actually 3. Okay. Now, finding this as 3 means that you have found the amplitude. So in this case now, this is going to be 3 sine AX plus C. Okay. And last but not least, find C. How to find C? It's just an offset. Remember I told you? So for this one, if you know that the amplitude is supposed to be at 3, right? But it is at 5, means that it has actually increased, remember? And like I shared with you the formula, remember? Maximum is actually amplitude plus the offset, remember? So you can use that and you'll find that it's actually equivalent to 2. Can you follow? Can you follow now? I talked about that just now. So basically, this formula is from the previous. You can just do that. So basically, it's like, okay, amplitude plus constant is equals to the maximum, right? That's why you will have it like this, okay? Can follow so far for this one? I think it's pretty straightforward, right?
Yep.
Cannot? All right. So I will stop here for today because because it's a lot of things for you to digest.
Okay.
But you should just remember that how to plot this. Okay, the few things that you need to learn. Okay. If you
Okay.
have got a soft copy, you can try to sketch. I think it should be okay to sketch on a piece of paper because you just have to sketch. Just sketch on a piece of paper and either use Desmo to check or use the GeoGebra to check. Okay.
Okay.
All right. Anything? Let me know. If not, I'll see you on Saturday. Okay.
Okay.
All right.
Thank
Take care.
you.
Okay. Bye bye.
Bye bye.
Bye.